At this moment, a chunk of ice and rock from another star system is ripping through our solar system at around 130,000 miles per hour, and NASA's Jet Propulsion Laboratory is tracking almost every mile of that flight. That object is Interstellar Comet 3I Atlas, and it is moving faster than any visitor we have ever seen come through our cosmic neighborhood. At that speed, 3I Atlas could go from Los Angeles to New York in a little over a minute, and it could circle the entire Earth in under 12 minutes. So the big question in this video is simple. How fast is 3I Atlas really? What does that speed tell us about where it came from? And what does JPL already know about its high-speed sprint past the Sun? 3I Atlas is the third known interstellar object ever detected passing through our solar system, after Oumuamua in 2017 and Comet 2I Borisov in 2019. Astronomers first picked it up on July 1, 2025, using the Atlas Survey Telescope in Rio Hurtado in Chile, a NASA-funded system designed to spot dangerous asteroids. Once the discovery was reported to the Minor Planet Center, observatories all over the world and multiple space missions began watching it. NASA quickly confirmed that its orbit is not a normal oval around the Sun, but a sharply open path called a hyperbolic trajectory. A hyperbolic orbit is a giant flyby curve that never loops back. That is the smoking gun that 3I Atlas did not form here. It came from deep interstellar space, will whip around the Sun once, and then leave forever. But the speed is what really blows this story open. Now let's put that headline number into human terms. NASA reports that 3I Atlas is racing through the solar system at about 130,000 miles per hour, roughly 209,000 kilometers per hour. That is around 58 kilometers every single second. For comparison, Earth orbits the Sun at about 67,000 miles per hour. So 3I Atlas is moving roughly twice as fast as our entire planet. Some measurements that look at specific points along its track even quote speeds above 150,000 miles per hour as it swings closest to the Sun. No matter which exact moment you pick, the message is the same. This comet is an extreme outlier in speed. It is not just visiting, it is screaming through the solar system. And here is the twist. That ridiculous speed is not something the Sun gave it. It carried most of that energy in with it, from billions of years wandering between the stars. So how does a comet get up to 100,000 miles per hour and beyond? Astronomers think 3I Atlas started as a regular icy body in another star system, maybe orbiting a distant star the way comets orbit our Sun. Then something kicked it out. The gravity of a giant planet, a passing star, or a reshuffling of that system's planets. Once it was free, it drifted through our galaxy for an extremely long time. Along the way, every close pass by a star, gas cloud, or cluster acted like a tiny gravitational slingshot, tugging its path and gradually adding or subtracting a bit of speed. Over billions of years, those small tugs added up. By the time 3I Atlas reached our solar system, it already had a huge excess speed compared to bodies that are bound to the Sun. The Sun's gravity sped it up even more as it dove inward, just like a skateboarder picking up speed in a half pipe. That extreme speed does not just make 3I Atlas exciting, it makes it very hard to study and even harder to trace back to its original home. Now, how do we know all of this is real and not just a cool graphic on social media? This is where JPL comes in. NASA's Jet Propulsion Laboratory runs a system called Horizons, which calculates extremely precise positions and speeds for objects in the solar system, including 3I Atlas. These calculations are based on hundreds of real observations from telescopes and spacecraft. According to NASA and JPL data, 3I Atlas follows an extremely hyperbolic orbit, with an orbital eccentricity of around 6.1, far above the value of 1 that separates bound orbits from escape paths. It reached its closest point to the Sun around October 30, 2025, at about 1.4 astronomical units, roughly 130 million miles from the Sun, just inside the orbit of Mars. Its closest approach to Earth will be around December 19, 2025, at about 1.8 astronomical units, roughly 170 million miles away. That is almost twice the distance from Earth to the Sun. Meanwhile, telescopes and missions from across NASA's fleet have taken turns watching it. Hubble, the James Webb Space Telescope, Mars orbiters like MRO and MAVEN, the Lucy and Psyche spacecraft, and solar missions like SOHO and Punch have all grabbed images or spectra. Hubble images show a classic cometary coma, a teardrop-shaped cloud of dust and gas around a hidden solid nucleus, along with a faint tail. NASA estimates that the nucleus is probably somewhere between about 1/3 of a kilometer and a few kilometers across, with an upper limit of around 3.5 miles in diameter. All of that is solid evidence. Brightness, position, speed, shape, gas, and dust. That is the part of the story we can measure directly. But fast evidence leads to fast questions. Anytime an interstellar object appears, one idea jumps onto the internet instantly. Is it an alien spacecraft? For 3I Atlas, a few scientists have openly explored that question. One well-known astrophysicist, Avi Loeb, has suggested that some unusual features in 3I Atlas's motion might allow for exotic possibilities, including advanced technology or even small probes being released near Jupiter. This is interpretation, not proof. It is a hypothesis about what the data might mean. Here is how the mainstream scientific view stacks up against that. NASA's observations show 3I Atlas behaving a lot like natural comets we already know, shedding dust and gas in a way that fits standard comet physics. Its hyperbolic orbit and high speed match what models predict for icy bodies kicked out of other star systems, not something that needs engines. No mission has detected clear signals or structures that would strongly point to technology rather than ice and rock. So far, the evidence is heavily stacked on the natural comet side. The alien probe idea is speculative and a minority view, interesting to discuss but absolutely not proven. The real wonder is this: even if 3I Atlas is completely natural, it is still a physical sample of another solar system's leftovers, flying past us at absurd speed. That is already mind-blowing. Whenever you hear interstellar object and record-breaking speed, it is easy to jump to disaster scenarios. NASA is clear on this point. 3I Atlas poses no threat to Earth. Its path keeps it about 170 million miles away at closest approach, and its orbit never comes anywhere near an impact course. Still, tracking 3I Atlas is part of the same toolbox NASA and JPL use for planetary defense. The same systems, like the Atlas survey, JPL's small body database, and the Horizons Ephemeris that follow this comet also watch for asteroids that actually could be hazardous one day. So while this particular object is harmless, the technology and teamwork built around it are exactly what we rely on to protect Earth in the long term. In that sense, 3I Atlas is not our enemy, it is our training partner. Even though it is racing away, the 3I Atlas story is not over yet. After perihelion on October 30th, 2025, the comet swung behind the Sun from Earth's point of view, making it tough to observe. As it comes back out and heads toward the outer solar system, it re-emerges for another round of observations in late 2025 and into 2026. Important moments on the watch list include late 2025, when space telescopes like Hubble and Webb continue tracking it to refine its size, composition, and dust behavior. December 19th, 2025 brings the closest approach to Earth in terms of distance, which is still far away but important for checking the models. In 2026, it passes near the region of Jupiter, where its path may get slightly nudged by the giant planet's gravity, giving scientists even more data about how interstellar bodies interact with our system. Every new measurement feeds back into JPL's models. That improves predictions not just for this object, but for future interstellar visitors. So, how fast is 3I Atlas? It is blasting through our solar system at roughly 130,000 miles per hour, with speeds climbing even higher near its closest solar approach, making it the fastest confirmed solar system visitor we have ever measured. That speed is the fingerprint of its entire life story, born around another star, kicked out by gravity, and supercharged over billions of years drifting between suns. By the time it hits our neighborhood, it is a bullet we only glimpse for a tiny fraction of its journey. JPL's tracking of its 130,000 mile per hour solar passage is not just about one comet. It is about learning how to read the traffic of the galaxy, how many of these visitors exist, what they are made of, and how well we can predict their paths. In the end, 3i Atlas is a reminder that our solar system is not a sealed bubble. We are on a busy interstellar highway, and every once in a while, something from very far away screams past and gives us a brief chance to learn how the rest of the galaxy builds its worlds.